Let's take a look at the MindSphere solution, the energy management for production. This solution enables customers to establish plant and enterprise-wide energy analytics. In this demo, we will use the example of a brewing company to demonstrate the value that the MindSphere application, SIMATIC Energy Manager, can bring to industrial customers. Breweries handle several complex process steps before the finished beer can be filled in bottles. The major steps are: first, water is purified. Next, malt and purified water are mixed. Third, liquid is separated, hop is added, and the wort is boiled and then chilled. And finally, the result goes to the maturation tanks for a few days or weeks before it is filled into bottles. In our example, production of 1 bottle of beer requires 1/4 kilowatt-hour of electricity, or almost 5 cents, assuming average industrial electricity prices. So controlling energy consumption addresses a significant share of product cost. In addition, since beer is a consumer product, increasing consumer demand for sustainable products also creates a motivation to find ways to reduce energy consumption. So let's start the live demo with the factory overview dashboard. On the screen, you can see the Energy Manager application, which has been started in our demo tenant. The factory overview dashboard consolidates all data in an appealing way. This allows the factory manager to check for energy flows and react immediately if she spots any KPIs going out of range. On the top left, you see a Sankey diagram which shows how electricity flows from the source through the factory to the main consumers, like purifying, mixing, and chilling. On the top right, there is a heat map which shows when energy is consumed. And at the bottom are various gauges showing, for example, the electricity and gas consumption per produced bottle. As you can see, electricity per produced bottle is outside the green range. The plant manager spots this and understands immediately that electricity consumption is not as desired and tasks the production engineer to have a look at this issue. The production engineer starts his analysis by looking at the regression analysis, which you can see on this screen. The red line indicates the estimated relationship between production volume on the x-axis and electricity consumption on the y-axis. Each dot indicates the observed consumption of a lot produced in the factory. You can hover the mouse over each dot to see which production lot at which time it indicates. The production engineer observes that the dots are scattered with a plus/minus 20% along the estimated consumption depicted by the regression line. This is more than he expects. There is a significant variance of energy required to produce a certain number of bottles. He concludes that there is opportunity to stabilize the process and reduce the amount of energy consumed. After finding the deviations in the regression analysis, the production engineer checks the electricity consumption for all lines to see which one shows anomalies. For that purpose, he uses the energy media analysis, which displays the consumption, CO2 equivalent, or cost for a specific line across time. The biggest consumers, chiller, mixer, purifier, do not show any anomalies, but he found a peak when looking at the filling line. As you can see, there is a spike in electricity consumption per filled bottle on December 6th. Hovering the mouse over the peak shows you that it occurred in the evening at 7 p.m. Let's see what happened on the evening of December 6th. For that purpose, we zoom in on the single day view to see how many bottles were produced. Hovering the mouse over the 7 p.m. bar where the peak occurred, he sees that only 16 bottles were produced and none in the afternoon. Nevertheless, the line was consuming the full amount of energy, letting the energy consumption per bottle rise steeply. It turns out that the filling line was ramped up after the cleaning break in the afternoon in a suboptimal way. The same behavior can be observed on other days as well, so it seems to be a systematical issue which needs to be discussed with the shift manager. With the previous analysis, the production engineer could identify the root cause of higher energy consumption and has now everything he needs to define with the shift manager a new ramp-up procedure which avoids unnecessary use of energy. Optionally, he can leverage this for other MindSphere applications, such as SIMATIC Collaboration Board, and take advantage of the fact that the MindSphere data model allows sharing of data and insights across applications.